So Rianne, I think, is more than capable of introducing herself. She's a developer, she's a solutions architect, she's a writer, and in fact, she didn't put this in her profile. She's an excellent presenter. So I'm really looking forward to tonight's session. I have to say that what I know about blockchains could probably be fitted into a rather small chain around my wrist. So I'm very, very happy to be in the position of being taught something that's going to be really useful. So without further ado, over to you, Rian.
Thank you for the very kind introduction. I'll hope to live up to it. So I want to talk tonight about how terrible blockchains are for most things, and then because you might think this is somewhat surprising from someone who's a real enthusiast about technology, I will explain why in a few cases they are worth the performance trade-off. First things first, if you want to follow me on social media, if there's anything you want me to answer after the webinar, then I'm at Rianne_is on Twitter. Sorry, a little bit of lag in the screen share. So yes, blockchains are not worth the performance trade-off, except when they are. I think Seb's more or less said everything about me, but just really briefly, I work primarily, or for the majority of the time, as a Ruby on Rails developer at Unboxed in London, who work on finding digital solutions to complex problems and are a rather marvellous agency, although I'm probably slightly biased saying that. I'm also an AWS certified solutions architect, and I've been involved in the cryptocurrency and blockchain technology space since 2013-2014, when I decided to build myself a cryptocurrency portfolio tracker because I was starting to trade back then, became obsessed with the technology, learned how to write smart contracts, and eventually had a couple of short-lived startups and wrote a book last year about cryptocurrency, and I'm in the middle of writing another book at the moment. But as I said, it's the tech side that's really interesting. So first of all, I'm going to tell you what you've probably heard from every single overexcited, non-technical person in a position of authority in a company, because we have all heard of Gartner's hype cycle, and we're all aware that when some magical, shiny new technology comes along, everybody gets terribly excited about it. And people who don't really understand tech tend to believe the hype side of it and push their technical teams to take on doing proofs of concept about things that they really don't have a clue about. And then the tech teams say, hold on, this doesn't quite work as promised, or it's not appropriate for our use case. So these are things that unbelievably, I have heard people standing up and saying at conferences over the last 5 or 6 years. People talk about how cheap blockchains are. They're cheap and they're fast, and you can store anything on them. They can solve all the world's problems and bring world peace. Well, perhaps the last two is a slight exaggeration, but only a slight exaggeration. And unfortunately, when tech teams have actually got hands-on with this, they have found out, rather unsurprisingly, that the last slide was a total lie, because blockchains are actually incredibly slow and cumbersome data structures. They're expensive because data is stored in multiple places. So that's just automatically pushes up the computing cost and the financial cost of running applications on them. You can't really store very much on them because it's inefficient to store any quantity of data in multiple places at the same time. And in most cases, and when I say most cases, I mean like 99 point something of cases, a traditional database would do the job better. It would do the job much better in most cases. So what's all the fuss about? It's blockchain tech is up there with AI, machine learning, big data, all these terms that people like throwing around as the future of technology. And given that we live in an increasingly tech-driven world, not just the future of technology, the future of humanity. So you would believe, listening to some people, that the future of humanity hinges on blockchain technology. Spoiler, it doesn't, but they are useful, as we're about to discover. So I would hazard a guess that everybody listening to this presentation now would have some idea of how blockchains, distributed ledgers, call them what you like, how they work. But for anyone listening who wants a reminder, they're essentially a data structure like any other kind of database or data store. The feature that distinguishes them, or one of the features that distinguishes them, is that the transactions are all bound together using varying types of cryptographic process, so that they can't be rearranged or deleted. So in other words, they're an append-only ledger, and that's combined with being distributed, by which we mean that they run on multiple computers, which can be actual hardware in different places in the world, or they might be virtual machines in a data center. The only commonality here is that each instance of a machine that runs the blockchain, that contains the blockchain data and does the validation, is that they are in different places at the same time. So in other words, anyone looking at a blockchain type structure can be reasonably assured that they are seeing the same source of truth. And that's what gives them this this reputation for not exactly being hackable, unhackable. We'll come back to that in a moment, but that's what gives them the reputation of being trustworthy. You don't need an intermediary to gatekeep or validate the data, because everybody can see the same data at the same time, and the architecture means that people can't delete any of the data. So they use those two different strengths in order to present this USP of being very trustworthy. And there's a lot of confusion around distributed ledgers. The purest form, if you like, is a public network like Bitcoin, which is open source software, which anyone can join. You also have proprietary software, which people can run between organizations in a consortium, or you can have open source software like Corda, which is used within the banking system, where there's no public network as such, but the open source data runs on and software runs on your consortium's machines, having been used like any other type of open source software. So I'm not going to spend the whole 40 minutes obviously talking about Bitcoin, because it is a subset of blockchain tech, but you can't really understand blockchains without understanding Bitcoin and without understanding the problem it solves. I talked a little bit about how you have this idea of transactions being cryptographically bound to each other so that they can't be reordered or deleted. But the key thing about Bitcoin is that it was the first solution to the double spend problem. Now, in terms of electronic money, the double spend problem is something that has plagued people forever, trying to solve this. So if you, in the days of purely paper money or metal money, you would hand over a pound note or a pound coin to somebody, and you would know that you had, as long as it was not forged, that they had given you their only copy of that pound note or pound coin. Digitally, the only solution was to do this via a bank, because you would trust the bank to say, we have debited this amount from this person's account. The £20 that they've just given you, they can't go and give to John Brown down the road because they only have £20. So you can't double spend the £20. And until Bitcoin came along in 2009, it was impossible to do this without an intermediary like a bank. So it's really difficult to understate the importance of Bitcoin as an open source network that anyone can join, anyone can run the software, and yet you know that if you send somebody £20 worth of Bitcoin, that nobody else will be receiving the £20 worth of Bitcoin that's yours. So it was really a huge technological step. However, when I go on to discuss the different use cases that people are getting excited about with the technology, I'm going to focus a little bit more on Ethereum and Ethereum-like networks, which allow you to do quite a lot more than just transferring money and solving the double spend problem, because within networks that allow smart contracts, you can actually run smart contracts indirectly on the Bitcoin blockchain, but that's a topic probably for another time. But for networks that are designed exclusively to run smart contracts, you start being able to do quite interesting things. So a smart contract is incredibly badly named, in fact. It's a piece of software, it's a small script that is not smart, and it's not a contract. People like to go into the whole fine print of whether code can be law. Code is not law yet. So these contracts, so to speak, I mean, I know we talk about contracts in software, but a smart contract has like a different meaning, really, like a pseudo-legal meaning rather than the exclusively software meaning of a contract. And the purpose of one of these scripts, these smart contracts, is to execute code in response to certain conditions. That sounds rather woolly and vague, so let's use an example. In the financial sector, you have, even with the high degree of digitization and automation that you currently have, a lot of in fact, most transactions still have to be settled to some degree manually, whether that manually is somebody clicking a button to update it automatically. They're intermediated. So if you take out an option, for example, and that option is stating that you believe a particular asset price will fall, that you need somebody to settle that, whereas a smart contract can automatically trigger a payout in certain conditions. So even without getting into financial markets, you can think of really everyday examples. For example, flight insurance, you need, and house insurance, you need generally loss assessors or somebody making a decision that something has happened. But if you have a smart contract for flight insurance, you can, for example, just have a group of people who contribute a certain amount into a smart contract themselves without the intervention of an insurance company. and the insurance contract will pay out if one person's flight, for example, gets delayed, because the contract can talk, I won't say directly, but indirectly via an oracle to the API of an airline and find out if your flight's delayed and automatically pay out. That's a fairly trivial example of a smart contract in real life, but extrapolating from that to large scale automatic execution of contracts like that is one of the reasons that people get so excited about them, and figure that this is a classic case of, although you are taking a trade-off in speed and cost, because transactions on public blockchains cost money, and they are slow because they have to wait for different nodes, which if it's a public network might have wildly different performance specifications and so on. So you're waiting for finality, or as close to finality as you can get in multiple places. You're paying for it. It has to be worth doing. And people are finding that in many cases it is indeed worth doing. So I always hesitate when I start putting together slides like this that feature the logos of companies who are working with blockchain tech and to a certain extent with cryptocurrencies, because the question is, how many people do you put on and who have I left off? I will have left off literally hundreds of blue chip companies off this slide, but at in the intro text for this presentation, which is presumably one of the reasons that you signed up, I did promise to highlight some of the use cases where blockchains were uniquely useful for some of these use cases, and to give some specific examples of them. So I highlighted a few companies where I thought we could talk in a little detail about some examples of where they're being used. So Maersk Shipping is probably quite a good place to start. And although I've got IBM separately, and I was going to talk about IBM separately, in fact, Maersk IBM teamed up, and they are a member of a consortium working on these solutions. And it may surprise you to know that that blockchain tech is already being used to track shipments around the world. And the reason that this is such a great example of where distributed ledger technology is genuinely useful is because you've got lots of parties to a shipping transaction who don't trust each other. And it's solving the trust problem, where suddenly all the performance disadvantages and all the costs start to pale into insignificance when you look at the problems that are being solved. So with shipping, for example, you have a supplier at one end, a purchaser at the other end. And obviously across a whole ship, like on the scale of, well, we all saw the Ever Given get stuck in the Suez Canal last month or month before, whenever it was, and you get an idea of the vast numbers of shipping containers on these ships. And every shipping container has containers within it, and each of those containers might contain multiple shipments destined for different purchasers from sellers in other countries. So you already have that trust relationship. These companies might have dealt with each other before, or individuals, they might not have dealt with each other before. As well as that, you have the shipping company who has committed to make sure that the goods arrive on time. And as well as this, you have countries that the goods are being exported from and imported into. And those countries might not, in fact, probably do not trust the individual companies, in the sense that it would be really easy on a shipment of that size to maybe not pay all the excise duties that are due, or to bring something into the country that maybe you're not supposed to bring into the country. And then finally, right at the highest level, you have different countries who might not trust each other. We can think of countries that have sanctions and don't allow another country to ship certain products internationally. So you have all this sort of interconnecting web of trust issues. And the way this has been solved in the past is by having an average of 2 kilograms of paperwork per ship, which has to be manually signed off. And in some cases, that manual sign off, as with the insurance or the settlement, might be somebody clicking a button. The forms might be digital. In many cases, these forms are still paper. And many people in many different countries per ship are tied up validating these transactions. Running these transactions and validations on a public network that is append only and undeletable from allows an audit trail which can be opened for scrutiny to any of the interested parties without having this process of manual sign-off and audit. And I think the shipping example is a really powerful one, because it means that you can have a ship full of shipments from different companies which haven't had to find a central intermediary whom they all trust to say this person validates that. Instead, you have technology taking the place of all these multiple thousands of manual interventions that might happen. So Maersk is always a good place to start. However, getting people to collaborate and cooperate is actually harder than the technology. And I was struck, especially with the Sainsburys example. I listened to the head of distributed ledger technology at Sainsburys talking at a conference a couple of years ago. And he was very enlightening. He talked very frankly about he was very rightly proud of the progress they'd made. But he said far harder than actually implementing the technology was implementing the relationships between the people that would allow them to agree to use these systems. And I thought that was really interesting, because I haven't really kept tabs on the progress of these, but this was an inter-supermarket project which was working with suppliers to validate supply lines. But obviously, if you have horizontal competitors like Sainsbury's is with other supermarkets, while the idea of a consortium might be really appealing for someone with vision, if you can't get the people you're collaborating with to agree on how the data should be presented, that is going to be the hardest part of it. And we'll touch on the technical problems of development and testing across multiple partners a little later in the presentation. The World Food Programme has used blockchain tech to make sure that food is distributed where it should be, and that it's not funneled off to people who might profit from it. That's obviously a very worthwhile case. And then right at the other end of the scale, you might think, why on earth have I put Manchester City there? It's not about their recent prowess on the football pitch, but because unless you've been living under a rock for the last few months, you'll have heard everybody going on and on and on about non-fungible tokens, NFTs, which are a often misunderstood and often misused way of registering art and collectibles on blockchains. And Manchester City have teamed up. If you're as old as me, you'll remember the days of football, of trading cards for football and other sports, which were incredibly popular, probably still are. And Again, with NFTs, it's the double spend problem that blockchains solve. How do you prove that a digital trading card of a footballer hasn't already been exchanged by somebody else? How can you validate that it's limited edition? So Manchester City have boldly and bravely entered the blockchain space. Whether it's just for publicity, who knows, but I thought it was an interesting development. London Stock Exchange have got many different programs around using blockchain tech for settlement. Facebook are there because, of course, they're launching their own currency. Currency remains a very compelling use case, obviously, and for that reason, we also have the Bank of England here up at the top next to Maersk, because again, the central bank digital currency that Britain may be going to implement in response to various countries around the world that have already got their own implementations up and running, like China. Amusingly, I noticed it was being called Britcoin, which I thought was rather good, but expect to see a fully digital currency arriving on the scenes at some later point. I'd love to go more into CBDCs, as there's something I'm very interested in, but I'm aware that time is short. I think I've really made this point that the key unique selling point of any kind of distributed ledger system is trust. Essentially, if you're a company or an organization and you're running a blockchain for purely internal use, unless you're an absolutely massive company and you have a lot of departments who don't trust each other, you're doing it wrong. The purpose really of having this append-only distributed ledger is that it removes the need for trusted intermediaries for companies or organizations who are transacting with each other, or who need to show entities like governments an audit trail that can be trusted. So we'll use a couple. I want to get directly into the issues of development and testing, but just really making the point that even with the problems that I'm about to reference, when you look at the potential benefits that those development and testing problems are a trade-off against, it does become worth it. So you can see, for example, if you have banks using blockchains for settlement systems, or companies using blockchain-enabled shipping solutions, how all of a sudden people being freed of hundreds of pages of legal agreements. You don't need firewalls because or if you're working on a sort of open permissionless system, you don't need firewalls because the security is actually baked into the architecture itself. You don't need you don't need a dedicated escrow system because a smart contract can do it. So the other thing to remember is that the technology is very much in its infancy. People often say that we are, with distributed ledgers and cryptocurrencies and blockchain and decentralized finance and everything like that, where if that was the internet, we're where the internet was in about, people used to say 1995. I don't think that's necessarily true anymore. We're maybe about in the year 2000, the internet. And anyone who can remember back to what the internet was like in the 1990s, I was working on a website for a major newspaper in those days, and it was we'd only just moved into the world of having dedicated content management system. Until the late 90s, we actually had a small PHP application which somebody in-house had built, and you just think that no organization these days would have anything like that. It is just staggering how far web technologies have evolved in the last 20 years. And this technology, distributed ledger technology, blockchain technology, is very much in the same kind of space we were at in around the year 2000. So let's have a talk about specifics, because it's all very well talking theoretically about these things. And I didn't prepare slides for this. I thought it was easier to explain in words, because I'm guessing that we have a variety of different skill sets and experience levels and interest levels among people who are on the call. So probably digging deep into analytics and performance stats is not going to be a terribly interesting thing, although I'm quite happy to talk at length about it later. But the problems with development and testing are completely turned on their head compared with what we're normally used to. For a start, the tech is all open source. So effectively, you're not really having to, say you're a bank and you want to use the Ethereum blockchain to run settlement transactions on. You don't have a database that needs setting up. I mean, obviously you do around the edges, but for the blockchain itself, you need somebody to write your smart contracts. But essentially, your infrastructure is completely outsourced. And I don't mean outsourced like running it on AWS or Google Cloud or Azure or anything like that. I mean completely outsourced, which in some ways is obviously something that you don't have to think about, but at the same time it's absolutely terrifying, because it introduces all these dependencies that people don't normally have to deal with if you're working in a traditional corporate organization, where you have release processes, where you can guarantee that the network has a certain amount of uptime. I'll give you some examples. Ethereum is, well, all public networks are by their very nature very unscalable as they are. So in terms of things like Bitcoin and Ethereum, you're talking about 10 to 20 transactions per second. And I don't mean 10 to 20,000, I mean literally 10 to 20. Fortunately, most transactions don't have to be done directly on the blockchain itself. But if you did, you can understand that effectively there is some kind of a queue for these transactions and to be executed. So you have this concept of a mempool, which all the transactions swim around in, waiting to be confirmed. And when things are running well, you know, that is seconds or minutes. But the point is that you cannot depend on this. And to give you a real life example, about 5 years ago, some friends and I launched a startup on Ethereum that was registering bicycle ownership, and we developed an app that worked really well on the test net, which is effectively Ethereum's staging environment, its pre-production environment, and everything just worked like magic. But then on the production environment, we suddenly realized that this people are used to seeing instant feedback from when they click a button, and you don't necessarily have that instant feedback. You might get instant feedback, but you have to prepare for the possibility that it will take some time and have a fallback solution other than just a spinner. You have to have messaging, or maybe you send your user off to do something else, or you have the transactions being executed on what's called a layer 2 solution, which is more or less instantaneous, because you never know at any moment whether these transactions that can be executed anywhere in the world by anyone in the world, how long they are going to take. Ethereum, for example, 3 years ago, it was 3 years ago, yes, there was a game launched on Ethereum called CryptoKitties, which was a really compelling game where you could breed cartoon cats and sell them. And it became wildly popular to the extent that it clogged up the whole Ethereum network at one point. And there were people who were trying to raise millions for their startups using the Ethereum blockchain, and they had to actually defer their the sale of their tokens because the network was clogged up with cartoon cats. Things have improved a lot since then. There are all these amazing new different solutions which mean that things like that aren't a problem, but it's always quite a good example to go back to, because if you're a developer or a tester and you're launching an application on a network that you cannot guarantee how many people are going to be using at any particular time, you can't performance test it because it's not within your control. And although you can, to a certain extent, performance test your own application, you can't simulate live network conditions beforehand, because the only environment you have to test it on is the test net, which is by a huge factor much smaller, with a lot less traffic than the main net. So you're having to think in terms of, what are my integration points? How do I test those? How do I mock something and test against it? You'll see that a lot of the solutions that have launched in the last year, 18 months, which promise massively scalable alternatives to Ethereum, do offer you out of the box easy setup and some kind of assurance that the transactions are going to be much faster. That's usually at a trade-off of having less trust in the network, I suppose, because they use different methods of reaching consensus between the nodes on the network, which might mean that they perhaps have less security baked in than, say, Bitcoin. So you always have that trade-off. But while things are certainly a lot more professional and a lot more outward looking now, I think it's worth pausing at this point to consider the fact that in more than 10 years, during a period when we've had major hacks on banks and other huge organizations, leaks of customer data, thefts and so on, that in more than 10 years, the Bitcoin blockchain has not been hacked, despite the fact that the source code is on GitHub for everyone in the world to see, despite the fact that there are billions and billions and billions of dollars tied up in the network that are a huge honeypot for an attacker. Yet despite this, despite the fact that everybody can see the code, and despite the fact that there's no firewall around the Bitcoin network and that anyone can run a node, despite all of this, it hasn't been hacked in 10 years, despite the fact that it's just maintained by a handful of I say volunteer developers. It is volunteer developers, although these days there are companies which also do pay developers to work on Bitcoin source code. But I just think it's something to think about when we think about the trade-offs of blockchain tech as compared with other technologies. And a final word, just explaining, we've been through all the reasons for the public networks being very slow, and that's why many institutions have decided to just run consortium blockchains between themselves using technology like Corda. But at the same time, it's really interesting to see a more or less complete turnaround. When I originally became interested in cryptocurrency, banks were starting to dip their toe in the water and and Barclays, in fact, was one of the more far-sighted British banks, and they invested in very early in 2014 in some crypto startups. Most banks withdrew from that over the intervening years, and the mantra then became blockchain, not Bitcoin. But then we've seen something of a reversal in the last 18 months or so, as banks start to see the value of having this independent, unintermediated settlement network. And we now see a lot of mainstream banks starting to dip into working again with public networks like Bitcoin and like Ethereum. Although I hasten to say that still the bulk of blockchain development within banking runs within these permissioned systems, which are running on software like Corda or like Quorum, which is a fork of Ethereum that JP Morgan developed. And you can see from banks' the point of view of the banks, that one of the great appealing things for them is the fact that they can streamline a lot of their processes and make them less manual. However, it's my belief, that eventually we're going to get to a point where you don't really want to have existing solutions with blockchains bolted on. You want to have entirely new business cases being dreamt up by all the things that you can do with this technology. It's not there as something that you can just bolt on to improve your existing processes. It's something to help people and companies devise whole new ways of working. Final word on scaling solutions. I talked a little bit about the ability of Bitcoin, for example, to be used as a global settlement layer. And we're seeing more and more development on all the main networks now, with transactions being bundled and attached in different ways to the main chain, therefore taking congestion off the main network. So revisiting my initial premise, blockchains are not worth the performance trade-off. They're really not. In many of the cases, people have used them in the past, just getting excited about the fact that they can apply them to existing business cases and that they will somehow magically transform process and efficiency. That's obviously not true. However, I really believe that, especially with these new scaling solutions, the idea of distributed ledger technology, especially on public networks, is only just starting to scratch the surface of what's going to be possible in the future. And I think that was dead on 40 minutes. I can talk about this stuff forever. In fact, you're talking to somebody who once overran a whole day workshop by an hour. I won't do that to you tonight, so I'll stop for now.
Thank you very much, Rhian. And so we have a one question so far, but I encourage other people to ask questions. There are two ways of doing that. There's a question panel where you can type in a question, which I could then read out, or you can just raise your hand and I will then invite you to ask your question directly, vocally, to Rhian. So the first question is, I mean, it's got a question mark on it, but it says, but you have to trust the technology. So I guess the point is, can you trust the technology?
This is an amazing question, and I will answer it by saying sunlight is the best disinfectant. So we've seen, not just with blockchain tech, but with all sorts of other technology over the last 10 years or so, a massive transition to open source. And one of the reasons that so many companies that it would formerly have been unthinkable for them to run open source software instead of proprietary software with SLAs and so on, is that if you have your repository somewhere like GitHub, where if you have people contributing, if you can examine the source code, or if you can pay people to examine the source code, if you can read what people are saying in the issues tracker on GitHub, that to me gives me, even without being I'm not a cryptographer, I'm an ordinary developer, but just the idea that the code is open there for anyone to pick over, anyone to audit, I think can give people, if not reassurance, because there is little reassurance with anything in life, it would give me a lot more confidence than having proprietary software that if something went wrong, I would then have to go through a lengthy and potentially unsuccessful reclaim process against a company who might not be able to foot the bill or who might not be insured. So if you're in the position of, I don't know, if you're a trading house, for example, where there are millions or billions at stake, having that level of trust and knowing that you have somebody to go after in the case of something going wrong might not be in some cases what you need. You might want something that a whole load of smart people have been drawn to work on and scrutinize and pick over, and just having that code in public view. That's one thing. So you have to trust the code and you have to trust the network. Now, trusting the network is a slightly different issue, because we've seen in the past what's called 51% attacks, which is where computers owned by people who are operating them on a public network can collude or work together in order to take over the network, because remember, to force a consensus of the shared history, you just need a majority, which is 51% of participating nodes to agree on a false version of history. If you have a network which is small, without the correct incentives to encourage people to behave honestly, then it's quite likely that you might get bad actors colluding to force the network to show a false history. However, the mathematics of these big chains which have network effect, effectively like with Bitcoin, mean that it's not within the interests of those running the network to collude, and it's also very, very, very expensive. We've heard a lot recently about energy usage on the Bitcoin network. That energy usage, I've got some really interesting resources on that. That's another topic entirely. But one of the net effects of this is that you would need to expend more money to rewrite the whole history of a blockchain, which is effectively what you'd have to do in order to show a false history, because the way everything is bound together, you can't just take out a bit of it, like deleting a field out of a database. And the cost of doing that would be greater than the cost of anything you'd gain, allied with the fact that participants in the network actually have a disincentive to prove that it's fragile. So there was a case a few years back when Bitcoin was a lot less expensive than it is now, when miners, the people who validate the network, a lot of this is done by what's called mining pools, when people work together to mine for optimum allocation of resources. There was a case when a consortium of mining pools came perilously close to the 50% mark. That hasn't happened since, but it was really interesting because they voluntarily drew back from that, because the cost to them of depriving Bitcoin of its of its trustworthiness would have been far greater than any temporary financial gain. So if you look into the various analyses of Bitcoin particularly, it's a fairly interesting read and analysis in terms of game theory, because it's all about incentives and what things make certain actions worthwhile. I'd say, I mean, who knows what happens in future, but I'd say that something that hasn't been hacked in over 10 years, despite the fact that it's been sitting out there with all this money in it, is probably quite a good bet compared with some proprietary software that you don't know what kind of insurances the company behind it has, and you can't examine the source code. You don't know anything about the motives of the people working on it. I know personally which one I'd find more trustworthy. Other people might have a different view.
Great answer. We've got quite a lot of questions actually, Ryan. So just to let you know.
Oh, amazing! That's really good. I only talked for ages on that question because I was absolutely terrified there wouldn't be any more.
No, we've got plenty stacking up. I'd like to ask Simon Love. If you unmute yourself now, Simon, have you got a microphone? Would you be able to ask Ryan your question?
Yes, I mean, you alluded to, sorry, can you hear me?
Yes, yes.
Yes, we can.
You alluded to the energy usage on Bitcoin and the like, and I mean, people talk about being a shortage of disk drives and things now, with them being soaked up for other sorts of blockchain. I'm not quite sure what, but what's the cost? There seems to be a trade-off here that's going on. On the one hand, Bitcoin, I mean, the blockchains, as you say, allow people to, or allow companies to employ less people. Less people doing jobs to do with checking the validity of things. And at the same time, we're soaking up a huge amount of resources. There seems to be some sort of social issues that might sort of come to the fore over the technology issues at some point. What do you think about that?
I think there are two, well, there are multiple questions there, and it's an excellent question, of course. Let's separate out the social issues from the energy issues. I've got a really interesting link, which I'll pass back to Seb after the presentation, which is very eloquently explained in a way much better than I can, some of the debates around energy usage. But it basically boils down to the fact that the existing banking infrastructure and financial services infrastructure already uses an awful lot more energy than Bitcoin does in terms of passing around pounds and notes, and before the pandemic, obviously flying people here, there and everywhere for meetings, or even just keeping huge tower blocks full of people with the lights on all the time, running data centers and so on. So people do make the assumption that somehow financial because a individual transaction in, say, by Visa or something might cost a lot less than a transaction directly on the Bitcoin blockchain. They look at that in isolation rather than looking at the overall infrastructure with the buildings and the people and the transport and everything else. There's also the fact that Bitcoin uses a lot of what's called captive energy. So as we know, there's lots of energy in the world that can't actually be transported yet from where it is because the costs would be too great. So things like gas that has to be burnt off on site, or you know, hot water in Iceland, that kind of thing. So you've got a certain element of captive energy being used for it. But I think the bigger argument is, what is the inherent value of a global settlement system that's independent of countries, that other networks can kind of hook into as a layer 2, and that in fact using energy to maintain this network could actually be a better use of energy than keeping buildings full of people travelling backwards and forwards to them and so on. It's a really complicated debate. I'm not really arguing one side or the other, but I think it's important for people who argue one side or the other to be aware of all facts. In terms of social issues, I absolutely take your point, but blockchain tech is only a small part of the technology jigsaw that is automating lives and automating a lot of jobs that were done manually before. It's part of a much wider argument about obviously universal basic income and things like that, about the nature of humanity. It's, you know, it's awful that people are being displaced with technology. One would hope that things like a whole reappraisal of what it means to be human, what living a productive life and things like that actually mean. I think, you know, those sorts of arguments have to come to the fore. Politicians have been very, very reluctant to tackle these openly because they, you know, politicians tend to get elected by saying we're going to get your jobs back, when in fact there are many, many, many jobs that for different reasons aren't coming back. And I think we need to have an honest debate about this. I agree that in the efficiency gains that I've talked about, yes, it is likely to lead to people losing their jobs, but probably no more so than in any other technology arena. And it's part of a really complicated discussion.
Thank you. I think we've got 5 more questions that I'd like to try and get through in the next 15 minutes. So first off, because I don't know what this question is about, Philip Mango, would you be able to unmute yourself and ask your question through
yeah, absolutely. So, thank you, Rhian, for a really engaging and amazing chat. Actually, I think I've learned more about blockchain in the last sort of 40 minutes than I've actually read about in the last year. So thank you very much. I'm an information security MSc student at the moment. Part of our core module is, or one of our core modules is cryptography. You alluded to cryptography a little bit in your talk. And my question is, you know, how long in the long term are we actually going to be able to assure the security of blockchain? Because it's not clear to me that there is either a common cryptographic standard or a common governance standard really for how cryptography is managed across those blockchains. And I believe, you know, going into the future, as you sort of alluded to, you know, we are looking at quantum computers coming in, which are going to be far more adept efficiently cracking some of the factorization algorithms that exist already. I mean, I take your point on from before about, you know, having open source code, etc. And I believe, you know, the best cryptographic algorithms work the same way. You know, they're open source. You can actually go and take a look at them. But more often than not, it's the implementation and how they're implemented that determines whether they're secure or not. And that normally has to be governed in some way, shape, or form by somebody. So I just hand over to you, but I'm very, very curious to get your thoughts on that.
Well, you probably know a lot more about cryptography than I do. Like I say, I'm a web developer and enthusiast rather than, you know, a cryptography expert. I'll just take those 2 points in turn. And I'm parroting something I heard somebody else say rather than because I know a lot about it. I was listening to a talk the other day where someone made the point that, yes, obviously quantum computing will ultimately be a threat. And presumably networks will upgrade to deal with it. But this person made the point that there are an awful lot more easy targets that would be cracked first before people started going after the Bitcoin blockchain. And it's quite possible by the time it was easy to tackle something like that, that we'd have far bigger problems with lots of people's systems being attacked. So that's one thing, and one would assume that development on, it's a big assumption, I know assumptions are dangerous, but one would, maybe hope's a better word than assume, that technology with different blockchains would evolve at a rapid pace as well. On the, it's a really interesting point you make about all the different blockchains and their security. Essentially, I'm working with a couple of different projects at the moment, and one of the things you learn if you talk to people who are launching different protocols is the expense and scarcity of good auditors, because you have companies who specialize in security audits for this kind of thing, and the really good ones do require such advanced knowledge that it's not like, say, when you launch a normal application and you hire a good pen tester, for example. I mean, we all know getting a good pen tester can be difficult, but they're not as scarce as blockchain audit companies. So you make a really good point, and it is something that I think keeps people awake at night, not so much the quantum thing, but definitely the security and who's auditing things.
Nice, thank you. Ashok Sinal, could you unmute and ask your question, please?
Hello. Yeah, so it's a question about smart contracts for you know, a couple of people or maybe a small group of people who would like to exchange contracts. So cutting out various other agencies, say, for instance, for buying and selling property. Is there an app which would actually do that? And I guess what's needed for smart contracts is sort of a killer app which would make it very popular. Does that?
Yeah. Oh, sorry, I cut you off before you'd finished.
That's okay.
That what you've just described is an excellent use case, but again, when I talked about the problem being with people, the problems around this are as much to do with the legal systems of different countries as they are to do with the technology themselves. So there are different companies that, as you so rightly say, smart contracts need killer apps, but because you're using smart contracts for different things, they tend to be different apps per sector. In Germany particularly, there are companies doing fractionalized property purchase of exactly the type that you describe, but that's because they're working collaboratively with government departments and lawyers to make sure that the code running is legal. In the UK, for example, yes, it would be entirely possible for a group of people to use an app to collectively buy, for example, a property, but then you run into things like conveyancing law and making sure, because that thing I said before about code not being law, you run into problems with things like property ownership. However, there are apps at the moment where you can, the flight insurance case that I described as a case in point, you can just, as of now, get together with a group of friends and make your own smart contract agreement that will pay out. So like I say, we're in the foothills at the moment, but everyone agrees. I think you've hit the nail on the head about the killer app, because the user experience at the moment for most things is not terribly good. And it's interesting, people often say that blockchain will be a mature technology once people realize they're not using it. And with a lot of apps at the moment, you're kind of painfully aware that you're having to do things that you're not used to dealing with. But the situation you describe, I think, will be commonplace sooner than we realize.
Excellent answer. I like the idea of it will be ready when we don't even notice it anymore.
Yes.
And
yes.
following on from that question, we've got a similar question from Martin Barringer. Martin, would you be able to unmute and ask your question, please?
I hope you can hear me.
Yes,
Yes.
I can.
Good. Yes, my question was that you gave many examples of organizations that are looking at blockchain solutions. I was wondering, how many of these have use cases in full production as opposed to just looking at the technology and experimenting with it? Just as an aside, you mentioned the airline cancellation compensation. I had read a little while ago that the attempt had been made to introduce that, but it had been dropped. Anyway, is that the case? And more generally, how many of these are really working now?
Really good question. The shipping example is in production. If you look at a site called TradeLens, as TradeLens, that's the consortium site for the technological platform that IBM are running for the shipping companies. China's own central bank digital currency running on a blockchain has actually been launched. It's running in 5 cities at the moment and is in the process of being rolled out. There have been the New York Stock Exchange is using blockchain tech for settlements. I mean, there are, sorry, I'm just trying to think off the top of my head. Facebook's blockchain-based payment system it was supposed to have been launched in March, but it's apparently launching I don't know if it'll be worldwide. It'll be in several countries next month, and that will be full scale, not pilot. Let me think. There was one of the car companies, but I can't remember which one, so I don't want to commit to that. This is already using the technology for its supply chain, and the first blockchain transaction on Corda has been done by the Land Registry. So while that is not live yet, I think they're pretty close because they've done a live transaction. Those are some examples. If I was prepared, I probably could have dug out a lot more, especially within financial institutions.
I'm sure they'll be listed in your next book, won't they?
I'd like to think so.
Yes. So
thank you.
Right. So I would like to invite Gordon Douglas to ask his question. If you would unmute, please, Gordon.
Hi, good evening. Yes, yeah, my question is really to state, is the current infrastructure, the internet, Web 2.0 as it's known, fit for purpose? Basically on the horizon there's some new concepts, Web 3.0 and ICP, the Internet Computer, which is previously known as Definity, where the intent, is a replacement for the, let's say, interweb. It's to get rid of the traffic problems due to the 7-layer ISO stack and flatten it into containers of functionality, which is spread out, using blockchains, etc. And it's just my feeling that the infrastructure is not fit for purpose. I spent 50 years of my life. I call myself a geriatric student, but I spent 50 years of my life in telecoms and traffic management and queuing theory and network management, congestion problems. It's been the vein of my life. And I think, we're talking about 30-year-old technology, which is the backbone of the internet.
Gordon seems to have muted himself, but I think we got the question there. So
yeah, really interesting question, and also fantastic to hear somebody with so many years of experience who is actively seeking out new frontiers and looking for the next big thing, because I might be biased being slightly older myself, but I think it's really important that people with varying times of experience within technology bring their experience to bear with this new tech. And also interesting that you talk about Definity. Obviously the Definity launch was massively hyped. They are a genuinely exciting project, and to explain to people who don't know about Definity exactly what they do probably would take too long, but really interesting that you've referenced them. But yes, I think in terms of infrastructure, we're moving to a completely different world now, and one of the things you referenced, Web3 as opposed to Web 2, and thinking about Web3 and the way we Web3 is widely seen as the internet of value as opposed to just the internet of information. And it's this idea that we're transitioning to an entirely new type of network where instead of just exchanging words and pictures and ideas, we can exchange things and value, and with virtual reality obviously becoming a real force in people's lives now instead of something in science fiction. This idea that you can step into the metaverse and buy things in the metaverse using Web3. You're right, Web 2 is not appropriate for the kind of world where you want to step into virtual reality and exchange value and make payments natively instead of going via a bank. Obviously a lot to say about hardware too, and about the state of the physical infrastructure. That's an entirely different debate. Again, you touch on a really interesting question. Web3 tends to, one of the ideas behind having a network fit for the future is that it's much more peer-to-peer than it is now. So people using mesh networks being able to natively sell excess capacity and excess computing power, all these things that Web3 makes possible that Web 2 doesn't. I suspect the pace of change that's happening is going to surprise people by the speed with which it's upon us. Just like working remotely in the pandemic, everybody was quite surprised by how easy it was in the end. And I think people will be surprised by how easy all this technology eventually makes new ways of living and new ways of thinking about things. But you did rightly make the point that we have a lot of pain points to get there, to get through before we get there. And one of those is just like the whole idea of trying to apply blockchain to existing business solutions, trying to apply Web 3 ideas to Web 2 infrastructure is not going to work. We need a new way of thinking about everything.
A new way of thinking about everything. That's a great call to action. And I've got one last question that is slightly political, I guess. But the gentleman who wrote it has gone, so you can answer any way you like, I suppose. And he asked, there have been multiple issues with the post-Brexit customs controls and associated paperwork. Would this be an opportunity to use blockchain to settle customs claims automatically?
Right. My heart sinks slightly when I hear this, because this takes us right back almost to the beginning of the talk. It's actually a fantastic question, because ultimately this is the sort of use case that that this type of technology was made for, and which I think we will see applied to this case. So in fact, it's a really, really, really good question. However, the number of times I heard people, especially in relation to Northern Ireland, saying, oh yes, we can do it with a blockchain, like it was a really trivial thing, like you could wave a magic wand and somehow the idea that using a blockchain would solve a problem that's obviously a much wider problem, but even technologically it's a much wider problem than just using a blockchain. So the answer to that would be, great question, it's exactly the kind of thing it would be useful for, but only in conjunction with a whole load of other technological infrastructure and things that would need to be in place first. You can't just, as I'm sure the person who asked the question is completely aware, you can't just say we'll use a blockchain and solve it, because it's like saying we'll solve that problem with an SQL database. You know, the database itself doesn't solve the problem. People thinking about the product and how it's going to work and all sorts of wider issues solves the problem. The technology itself doesn't solve the problem. And that's probably quite a good last question, I suppose.
Yeah.